Alright, in the previous video, we have seen how we can create new objects of the type person. We have created a custom class called pPerson with 4 properties, name, age, height, etc. And we can see how we can create new objects. And for each one of those properties, we can assign values so that we can start manipulating these objects around, right? And then we've seen how we can print each one of those values, Jose Luis and Jane and all their properties, right? However, this code is a little tedious because I have to actually manually, for each one of the properties, assign initial values, which is kind of tedious. And maybe for 4 properties, it's okay. But if the object was more complex, then it's probably way too much. So there's got to be a way to perhaps make this process of giving objects initial values a bit more streamlined, a bit faster, right? And there is such a process, and the way we're going to do that is by using the constructor function. All right. What does that mean? Well, remember that we said that whenever we want to create a new instance of a person object, for example, JL or Jane, we use this keyword called new. But what this is doing internally under the hood is that it's calling a special function similar to the ones we've seen before, but with a few nuances. It's calling a special function that creates that new object and returns a copy of that object, right? Well, it turns out that we haven't explicitly declared that in our class yet, but we can actually declare how that constructor function works. And let me go here. What I'm going to do here is I'm going to declare the constructor, and the constructor is going to be a special function that we use to create new objects. The way these constructors are declared is that you just use the exact same, this is a C# specific thing, you use the exact same word that you use for the class. So the name of the constructor function has to be exactly the same as the name of the class, all right? And inside of this constructor, I can write any code that I want to run anytime a new person object is going to be created. What does that mean? Well, because this is a function, the functions actually can accept input data. So what I can say is, instead of calling the function empty, so instead of calling the car factory and saying, hey, you want to send me a car? And then they send you whatever, right? Or they let you then, once you send you the car, they let you choose the color and the cylinders like on the spot, like we're doing here. Instead of that, what you can do is you can say, well, maybe when I create the object, I want to give it some initial values through the constructor function. Or with the car metaphor, if I call the factory, I want to tell them like, hey, can you send me a car? And can the car be red? And can it have like 8 cylinders and 4 wheels? And then they send you a car that has all those properties. Well, similarly here, in the constructor function, I can add arguments to give people the possibility of sending initial data for this constructor. So for example, I can say the first argument that it might take is going to be the name. The second argument that it might take is going to be the age. And the third argument that it might take is going to be the height, which is going to be a double. All right. And let's treat that a little different, okay? So what we can do now is, because the constructor has been given data, what we can say is whatever data is coming in from the constructor, I want to store it inside of the value of name, inside of the value of age, and inside of the value of height. So what I can do is I can say name equals name. What? This is very confusing. This is very confusing because I have chosen to call the argument name with the exact name of the variable name. That was really, really confusing. Let me actually rename this for the sake. Let me do N, let me do A, and let me do H. This is really, really bad practice to do single letters here. But what I can say is, so that it's a bit clearer, I can say H equals A and height. Oh, sorry. Yeah, my keyboard is not being working great lately. And height equals H. What I'm doing here is I'm saying anything that you give me when you're calling the constructor, I want to take that name a string, and I want to store it inside of my internal variable called name. I want to take the A value, and I want to store it inside of the age property inside of my object. And I want to take the age value and store it inside of the height variable inside of my object. So basically, whatever you give me, I'm going to take it right away, and I'm going to store it in my internal variables. How does this change what we had before? Well, for example, now the trick is I can say, well, I want to create a new person, and also we have to remember that this has to be public so that it can be accessible by code that lives outside of the class. All right. So let me say I'm going to create a new person, right? And I'm going to open close parentheses, and you can see how I'm already given these suggestions N, A, and H. All right. So what I can say is this new person is going to be called Jose. All right. His age is going to be 150 years old, and his height is going to be 5.9. All right. And then I'm going to remove all this stuff here. And I'm going to also comment this out for the time being. All right. And I'm going to run this code. You can see how now I have now in my console is printing the name, the age, the height, and is alive, which for some reason initializes by default to false. I'm going to talk about that in a second. But I want to make sure that we understand what is happening here. When this line of code executes, we are passing to the constructor function 3 data points: a string, an integer, and a double. When the computer reaches here, this N has the value of Jose, this A has the value of 75, and this H has the value of whatever, 5 point something. And then that string, Jose, gets stored inside of this variable. This thing, 75, gets stored inside of this variable, and this one gets stored inside of height. So we're basically, again, the metaphor is I'm calling the car factory, hey, red color, 4 cylinders, 4 wheels. And then the guy who picks up the phone takes those data and then just like throws them into the car, and that's what they give you. All right. And then that saves us from the hassle of having to manually change those properties ourselves. So for example, now for Jane, I can say Jane I'm going to create a new person with a name Jane, with an age of 25 and with a height of 5.8. And then as I print this, I don't need this anymore. You can see that now Jane has all these values by default. Not by default, but because I have used them, I have used these values to initialize the person object. Okay, let's talk about a couple of things that I did not like during my implementation. And as I said before, I really don't like that. It's not good practice that you use very cryptic names for arguments in constructors or in any function in general. So because like when I say here, I'm going to create a new person, blah, 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 you see that the autocomplete gives me NaH. What does that mean? It's very difficult to understand, right? So we have to be good designers and design things that are easy and intuitive to understand without needing explanations, right? So I like the idea that this is going to be called name. I like this to be called age, and I like this to be called height, all right? But then we have a very confusing situation where age is equal to age and height is equal to height and blah, blah, blah. And this is very confusing. What is what, And actually the compiler is saying like, oh, you're assigning the same thing to the same thing, So actually you will see in C# that very often code that is written inside of classes, whenever they want to make a difference between what is coming in as an argument from the function and what is actually a variable that belongs to this particular class that we're living, this object, then very typically you will see the word this, the keyword this, to refer to, hey, name is what's coming from the argument, but this one name is the one that belongs to this object that we're living in, the one that we are currently inside of. All right. So this is optional. So if this had been before, when these were called N, A, and H, you saw how I didn't have to write this dot name because the compiler assumed that name, the only thing that it found that was name, was the variable that lived inside. So that's why you didn't need the this dot. But when then there is a confusion with names, and it could be names are similar, then it's easier to use this to differentiate. Also, it's kind of good practice because it makes code easier to read when you use the this dot notation. All right. And in some other languages, like for example, JavaScript, this dot is actually mandatory when you're referring to variables that live inside of the class. All right. So you will see this very often. And I personally like using the this dot notation to refer to. It makes code easier to write and easy to understand, I think. Okay. Another thing that we haven't seen is what is happening with isAlive. So when I create this object, I haven't really explicitly said that whether if this user is alive or not, right? But I already get a value for isAlive. So I get here false and false, all right? What happens is that when I create variables that are inside of a class and I don't give them values, they default to whatever default value those types usually take. So for strings, it's an empty string. For integers and doubles, it's the value of 0. And for booleans, it's the value of false. Okay? So we could have said, and so that's why right now, without me working with the giving it any value or whatever, that's why it defaults to false. We might feel inclined to say, well, then maybe what you need to do is add here another argument to explicitly say if this is alive or not. However, I would argue that if we have to specify all the parameters of everything, it's a little tedious. So what happens is that actually inside of the constructor, we can initialize variables. We can initialize values of our internal values, not just from data that is coming outside from the constructor, but through calculations that we can perform internally inside of the constructor. Remember, the constructor is a function, and just here we're making assignments, but we could have like a very elaborate algorithm running in here that performs like very complicated operations and then returns some values that we use to initialize the object. Okay, so for example, a very simple rule here could be if age is less than 0, or if age is if age is greater than some value, so for example 150, whatever, then this is alive is going to be equal to false. All right. Otherwise, we could argue that if that's not the true, then this user should be alive. Okay. For example, right? And then in that case, if I run my code now, then you can see that both Jose and Jane both are true, both are alive. But if I decide to say that Jose has an age of -10, you will see how Jose is the date, so he's not alive anymore, basically. Okay. Let me show another example of this idea of using the constructor to perform calculations to smartly initialize the properties of an object. So, for example, here we're working directly with the age of an object, right? For example, for representing persons. But it turns out that when, for example, I would argue that by design, if we're going to be representing people, the age of a person will probably change over time, right? So if I write this program now, but then I run it in 3 years, then the age would have changed. And then, but the age would have changed in the real world, but not in my program. So I would argue that by design, perhaps to representing people by their year of birth instead of their age might be a better design choice. Okay. So for example, what I can do is I can say, well, let me redesign people objects, and I'm going to say that instead of age, I'm going to have now this thing called year of birth. Okay, and I'm going to store this here. Year of birth, sorry, uppercase, you know, year of birth is going to be equal to whatever I get out of the constructor. Okay, and I'm going to cancel this code out right now. And then Jose was born in 1950. All right, and Jane is a millennial, so she was born in the year 2000. Okay, and this is going to be year of birth and year of birth. So if I run this code now, you can see that now instead of age, we're working with years of birth. All right. I can now modify this and say, well, then the factor of whether if someone is alive or not is not so much anymore about an age range, but it's more about comparing the year that they were born to the year that we are currently right now. So something that I can do is in C# you can get which year we are living in by saying I'm going to define a variable called current year here in the constructor, and that's going to be equal to the date time object. This is like the console class or the math class. There's a date time class that has a lot of functionality for working with dates. We can access what's called the now property. So this basically gives me a datetime object that represents right now. Okay, and from this object I can also get the property year. So you can see how interesting this is. Datetime has a lot of properties, one of them being now, and that property also has like nested properties, being the year, the second, the hour, the day, etc. So if I get here the year, you can see that it gives me an integer value representing where we are right now, this year. Okay, and then what I can do is I can say if this year of birth is less than current year, all right, then this is alive equals false. Otherwise, this is alive equals true. All right, simple. So let's see if this works. I'm going to run this code. Jose was born here, then he's not alive, and Jane is also not alive. So maybe year of birth has to be greater than, yes, so sorry, I missed that one. So if Jose, if year of birth is, yes, so Jose is alive, Jane is alive, but if Jose was born in 2025, I'm recording this in 2020 if you're seeing this from the future, all right? So you can see that Jose is not born yet, but Jane is alive, okay? So I just wanted to do this as a way of showcasing that the constructor can actually have some calculations to make sure that given the initial data that you give it, you have something to work with, and that you can perform smart choices to give these values initial property values. To give these properties initial values. Okay. All right, let's move on now. Okay, oh, sorry, I forgot. And constructors, just like any other function, they also accept overloads. So you can create different ways of creating objects. So for example, I'm going to say, this is very nice. It accepts persons that have a name, a year of birth. But what if I just wanted to create like really quick people, all right? So what I can do is I can say, well, I'm going to create another overload, which is going to be, let me create persons, but only with their names, all right? So I don't want to give them any other information. So what I'm going to do is I can say, whenever I'm only given a name, so I can say this name is going to be equal to whatever I am given as data. This year of birth is going to be right now. So whatever, because you're not giving me any information, I'm going to assume that this person was born right now, this year, right? I'm going to assume that the height of this person is going to be, because it's a baby, I'm going to assume that, I don't know, it's like, how big are babies? 2 feet? I don't know, 2 feet. I don't know if that's a big or a small baby. And I'm going to say that this is alive because it was just born right now, is going to be true, okay? What this means is that I can create now, for example, I can create a new object called baby that I'm going to call cutie. This is a terrible example, all right? But if I copy paste this and I say, can you give me all the properties, the name, the year of birth, the height, and blah, blah, blah of Cutie, then you can see that my third object, Cutie, was born this year, 2020. It's 2 feet high and it's alive because it was just born like right now. All right. So that was just to say that constructors accept overloads. And if you want to remember what an overload is, you can go back to my previous video on functions and the idea that we can define functions that have different names, the same name, but different signatures, different types of arguments and different amount of them to work with data differently. All right. Okay, so let's move on now to these people have properties, but what can they do? What is their functionality? All right, let's learn how to give objects functionality in the form of methods and internal functions.